In this short segment, I want to talk about the type float of floating point numbers in Haskell. So this is the main type of real numbers in Haskell, which are written with a decimal point, and the idea about a floating point is that you can have as many values, digits after or before the decimal point as you wish, rather than fixed point numbers where you would have a fixed number of positions after the decimal point. Now, in practice, there isn't an unlimited number, but this allows the widest possible representation. So these things are written by having the whole number part followed by a full stop, followed by the fractional part to base 10. But it's also possible to use scientific notation where you write a value between 1 and 10 followed by e, and then an exponent, which is a power of 10. So if we write 2.35 e5, that means 2.35 times 10 to the power of 5, which is 235,000. 235,000.0, because here we're dealing with floating point rather than whole numbers. So that's a more compact way of writing things down. You don't have to write, and if you have something that is would have 100 zeros after the decimal point, that's all summarized by having a negative exponent of something like 100. So that's a much more compact way of writing these things down. But this is all standard stuff that I'm sure you're familiar with in other languages. I've taken this figure from my book here, which tells you the major functions over floating point numbers. Some are the same as addition, subtraction, multiplication, are the same operations as you see over integers, but division is different. It's denoted by a slash, and there are two forms of exponentiation. One is exponentiation by an integer, or by a natural number, and the other is exponentiation by an arbitrary floating point number. There are comparison operations. I guess perhaps the only thing it's worth remarking about here are the functions ceiling, floor, and round, which take a floating point number to an integer. Ceiling takes it to the next integer above the value. Floor takes it to the integer below, and round takes it to the closest integer. I mean, but again, these things are standard. So that's there for you to absorb, but that basically covers all we need to know about floating point numbers in Haskell.